Hi, I'm Namin An from KaiSTI. In this paper, I work with my wonderful collaborators Inha Kang and Minyan Lee, and my encouraging advisor Hyunjung Shim. In our paper titled Blind Deposition Bias in Language, we probe mid-layer representational bias in Vision-Language Encoders for zero-shot language-grounded spatial understanding. The core message is that pre-trained VLEs already encode where things are and can stay stable across languages, but that structure is buried at the final layer and we recover it entirely at test time. Most zero-shot referring segmentation pipelines bring candidate masks using the encoder's final layer image-text similarity, but that layer is optimized for global semantics, which collapses fine-grained structure. Our two probes on this slide diagnose this problem. On the left, the spatial probe. We take the same object placed at different locations and measure pairwise cosine similarity across layer depth. Similarity drops in the middle, meaning those layers are position sensitive, then rises sharply at the final layer, which becomes spatially biased, almost position invariant. On the right side, the multilingual probe. We embed the same sentence in 10 languages. While at the mid-layer, the language centroids are tightly packed, at the final layer, they spread far apart to 84.18. So the conventional interface is failing at both spatial precision and cross-lingual stability. So if the cues aren't gone, can we read them out? Yes. On the left is our raw spatial map. Without negation, though, we observe the opposite visualization phenomenon, where the target foreground is anti-correlated with the query, so the map lights up everywhere except for the target object, in this case, the rabbit and eggs. This is because cosine of negative u equals negative cosine. A simple principal sign flip inverts this into a clean foreground-focused map. On the right side, we sweep exit layers 1 through 11. Exit layers are noisy and diffuse in the early layer, but to the mid to late layers produce sharp, well-localized activations on the referred object, the trees and the chair. This confirms the finding. Structurally precise grounding signals survive in the encoder and are simply attenuated at the final layers. This motivates our B2G, a training-free plugin on frozen VLEs following a probe, select, and ground paradigm. In the first probing stage, we run the image and referring expression through the encoder, apply that negation before the projection layer, and form patch-level similarity map. In the selecting stage, we pick the best layers automatically. For the vision, we shuffle image tiles and score equivariance gamma. The layer that changes most under permutation is the most positionally sensitive. For text, we take parallel translations, here English, German, Chinese, and pick the layer with the highest cross-lingual language consistency, 5. In the grounding stage, the selective vision layer builds our PMAP, which we cluster into a spatial guidance mask and use to re-rank candidate masks by overlap. For multilingual queries, we compute a centroid across translations and inject it into the text embedding. No gradients are updated and no attentions are recomputed. As a result, the final table on the left shows consistent gaze across every backbone, clip, SIGLIP, and DFN, on top of already strong baselines, reaching up to plus 6.5 MIOU on DFN. The qualitative examples show B2G correctly grounding hard queries such as a boy in pajamas in a suitcase with more diverse and accurate top T masks. The automatically chosen layers concentrate in mid-depth and mid-layer grounding. Finally, on the bottom right, our method outperforms both the baseline and the final layer centroid fusion with gains of roughly 8 to 9 points at a modest 1.5 inference overhead. Finally, in the text-to-image retrieval results, where we fix the image branch so every gain is measured purely from the text side, The table on the left shows recall at 1 improving by 4.22, 2.77, and 6.42 in average across the 3 data sets, dramatically rescuing the underperforming languages like German while still improving English. Qualitatively, the baseline fragments the same query into different masks per language, whereas B2G collapses them into one consistent prediction denoted as the alt tag. The translation sensitivity table on the right top side indicates that our B2G is effective regardless of the translation system, whether it's NLLB or GPT. Our donor language analysis shows no single anchor is universally the best, and the number of languages does not matter. Finally, on the text side ablation, final layer fusion actually hurts while mid-layer sample mean injection is the strongest across RefCoCo datasets. That's B2G recovering spatially precise language robust grounding from frozen VLEs at test time. Thank you for watching. 감사합니다.